right, welcome to your redo opportunity for your motion test. What you will need to do is basically do everything that I do and follow along. If I make a note or write something down, you make a note, write something down. And we're going to work through all of the questions on the motion test together. So let's get started. Number 1 says to select all of the following that describes acceleration. All right, well, your copy of this paper is blue. But I'm going to remind you, acceleration occurs whenever an object speeds up, slows down, or changes direction. Okay? So I look. There's one of them, speeding up, slowing down, changing direction. Those three. Okay? No motion. Acceleration is a change in motion. And so if something's not moving, they're not moving. They're not changing how they're moving. They're not moving. Speeding up, an object is changing the way it's moving because it's going faster and faster. Moving at a constant velocity. That means it's not speeding up, slowing down, or changing direction. So there is no change in motion. This object's moving, but it is not changing the way it's moving. An object slowing down, it's changing the way it's moving. It's slowing down. And then changing direction. Yes, it's changing the way it's moving because its direction is changing. So those three qualify as acceleration. Number 2 says a 55-kilogram student was riding a skateboard to school. He traveled 200 meters in 40 seconds. What was the student's average speed in meters per second? Okay, so first of all, they give you 55 kilograms, they give you 200 meters, and they give you 40 seconds. And actually, they gave you more information than you needed, and they did that to you on purpose so that if you were kind of unsure, you might be confused. 55 kilograms is mass. Kilograms is a unit of mass. 200 meters is a distance. 40 seconds is a time. What is the student's average speed? Speed is going to be our question mark. Okay. So now I go shopping for a formula. Speed is equal to distance divided by time. I don't even need the mass. I just need distance and time. Okay? So 200 meters divided by 40 seconds. Cancel out a set of zeros. 20 divided by 4 is 5. Okay? 5 in front of the decimal. Or you could have said 5.0. That's okay too. Okay. You can't really put it in on DMAC, but it would be 5.0 meters per second. That would be its unit. Okay. Number 3, during investigation, students placed a toy car at the top of a ramp and recorded the distance and time at different intervals. The graph shows shown above, well, shown below, is a record of their data. So here we go. Looking at, all right, so the question over here on the next page, it says, what is the average speed of the toy car in the investigation? Okay, average speed is total distance divided by total time. So this one's a little bit tricky. You think that you might have to do something crazy because the line is curved. The fact that the line is curved means that this toy car is accelerating or speeding up. But if I look over here, it covers a total distance of 20 meters in a total time of 5 seconds. So speed is distance divided by time, total distance divided by total time in this case, and that's 20 meters divided by 5 seconds. And this time we get 4 meters per second. Okay. It's not going 4 meters per second all the time, but on average, that's what it's doing. Because obviously right at the beginning, it's going less than 4 meters per second. And at the end, it's going more than 4 meters per second. But on average, for the whole thing, 4 meters per second. Okay, so let's find our answer. Okay, our answer is B, right there. Number 4, a group of students are going on a field trip to the Dallas Aquarium from Waco. The distance the students will travel is 96 miles. What would the average speed of the bus be if it took 1.5 hours to drive to Dallas? Okay, so first of all, what do we have? We have a distance, and that is 96 miles. We have a time, 1.5 hours. And it's asking for average speed. Speed or average speed is distance divided by time. So I'm going to take 96 miles divided by 1.5 hours. And we're going to do a little brain exercise. We're not using a calculator, so we'll just use some of the spare room up here. 96 divided by 1.5. Okay, I'm going to move my decimal. That becomes 960 divided by 15. 15 will go into 96 6 times. 6 times 15 is 90. 96 minus 90 is 6. Bring a 0 down and make that a 60. 15 will go into 60 4 times. Okay. And that's going to give us a 60. It's going to give us 0, and I get to quit because I have no remainder and I went all the way to the digit next to the decimal, so I'm done. So record your answer in the text box below. Well, my answer is 64. And even though you guys couldn't type it in on the DMAC test, it would be miles per hour because I had miles for my distance and hours for my time. Number 5, the table shows the motion data for 2 objects during 2 trials of an investigation. Which object travels at the greater average speed? Okay, so remember, speed or average speed is distance divided by time. So object 1, trial number 1 is 400 divided by 20. Knock off a set of zeros, and that becomes 40 divided by 2. And so that is an average speed of 20 meters per second. Trial 2 is 600 meters divided by 30 seconds. Again, knock a set of zeros off. 60 divided by 3, 20 meters per second again. So 20 meters per second for the first trial, 20 meters per second for the second trial. The average for both of those trials is, it's easy, it's 20 meters per second because they were both the same. Okay. Object 2 traveled 55 meters in 11 seconds. 55 divided by 11 is 5 meters per second. And then 45 divided by 9 is 5 meters per second. Okay, so that's easy also. The average there was only 5 meters per second. Okay. All right, so let's look through our answers. First of all, which object travels at the greater average speed? We need an answer that starts off by saying object 1. Okay, so this might be it, but not necessarily. This might be it, but not necessarily. Object 2 is not faster, so I can eliminate C and D. Okay, All right, so let's look at the rest of the answer. Object 1 is faster because it travels the greater distance per unit of time. Like what it's saying is it's traveling 20 meters every second versus object 2, which is only traveling 5 meters every second. So that sounds pretty good. It's probably the correct answer, but let's double check. Object 1 because it travels the longer amount of time. That just means the time trial was longer. It doesn't necessarily mean that the speed was faster, okay? Yes, it does have a longer, the two time trials are both longer, but it's the distance divided by time that I'm really interested in, okay? All right, so A is going to be our answer. And there we go. All right, join me for number 6. Number 6 says, a student graphed the position of a cart during a 7-second time interval. So we've got position on the y-axis, time on the x-axis. Which statement best describes the cart? Okay. The cart was stationary with a velocity of 0 meters per second for the entire 7 seconds. That is not the case because the position number is changing over time. If it was not changing over time, then the line would be flat. So 0 meters per second equals a flat, or really I should say a horizontal. Okay. So not A. The cart was stationary except for a short burst of acceleration at 0.5 meters per second squared. No. Again, stationary is going to be flat or horizontal on a distance versus time graph. And then it says for a short burst of acceleration, then it has some funny hook on the end. That's not what we've got. The cart moved at constant velocity of 0.5 meters per second for the entire second. Well, I don't know. How much, let's see, did our position change? It looked like it ended at 7 and started at 2. So that is a change in y values of 5. And let's see, 7 seconds. 7 minus 0, that's our change in x values. So my slope is 5 divided by 7. Cart moved at a constant velocity of 0.5 for the entire... Oh, that's 5.5. Sorry. Okay. So that's 5.5. No wonder. 5.5. That's not 7. 7's way up here. All right, 5.5. 5.5 minus 2 is 3.5. And 3.5 divided by 7 is a half, or 0.5. Okay. So I can use the change in y values divided by the change in x values to get my slope. Change in y values was 3.5. Change in x values was 7. 3.5 divided by 7 is 0.5. Car accelerated at a constant rate of approximately, okay, if it accelerates on a position versus time graph, acceleration, something speeding up on a distance versus time graph or a position versus time graph, it's going to curve. And that's not what we've got. So it is C.